I am thrilled to be here, and I thought I'd start with a quick census. So who raise your hand or shout out if you've played on Zooniverse before? All right. And any favorite projects in Zooniverse you've played with? Chimpanzee, all right. Any others? Penguins. Penguin Watch. Everybody loves penguins. So Galaxy Zoo, awesome. So these different icons are a few of the many Zooniverse projects. And what Zooniverse is the online platform for people-powered research. So that means having the public, like you all, work with researchers to make their way through these huge data sets we have. And in the next few slides, I'll describe what that is all about. So the origin story is that across the sciences, across the disciplines, we have these growing, huge data sets. And an example, in 2007, the Sloan Digital Sky Survey, so that telescope in the lower right in New Mexico, was taking images of the northern sky and built up this catalog of 1 million galaxies. And so many research questions depended on knowing of those galaxies which ones were spirals and which ones were elliptical. So the left-hand galaxy being a beautiful spiral like our Milky Way galaxy, and the right hand more of a soccer ball shaped. And computer algorithms fail at figuring out which galaxy is which type in really interesting ways. But humans, or our special cousins, the chimps, are really good at recognizing patterns. And so we thought, okay, let's just throw our human ability to recognize patterns and go through those 1 million galaxies. So astronomy professor, starts doing this, gets to about 100 galaxies, and poops out. He's like, I'm done. So then you get together a group of astronomers, and they write one of the early Sloan Digital Sky Survey papers, and they classified 10,000. Remember, there's 1 million galaxies that are part of this survey, so that's still just a fraction. And then you have, and why I've called this the Schwinsky number, is a very special grad student at the time named Kevin Schwinsky, infamous astronomer, spent an epic month and classified 50,000 galaxies because he doesn't have better things to do. And that still was just a mere fraction of the 1 million. And so this is where the idea of crowdsourcing, turning to the crowd, taking advantage of, here's just a subsection of the 1 million people who went to Obama's inauguration ceremony. And we all know, you and me included, we spend 16 years every day playing Angry Birds. So let's take advantage of that cognitive surplus and apply it to research. So Galaxy Zoo was born in 2007 and launched what we now call Zooniverse. And the idea was just to go in and classify those galaxies. And in the first 2 days, they were having 50,000 classifications an hour. So all of Kevin's work for a month done in an hour. And since then, there's been 350,000 volunteers participating in Galaxy Zoo and millions of classifications complete. And so 8 years later, we're at the Zooniverse, which has 38 different projects you all can participate in across the sciences. And a really important motivating factor, sort of part of our motto at Zooniverse, is that it's about producing real research. So there's 94 peer-reviewed published articles that have come out of these projects. And it's all built, so the Adler Planetarium and Oxford University house 16 developers and a designer, data scientist to make Zooniverse as a platform happen. But it all depends on you, the public. So 1.37 million volunteers around the world have contributed to making these Zooniverse projects happen. And so we're now at an average of about 100,000 classifications a day. And there's a whole discussion forum aspect to the projects where a lot of the really interesting serendipitous discoveries occur, and that's through comments and sort of just a Facebook for Zooniverse. So in the next few slides, I thought I'd showcase a few favorite projects that probably came up at the start. So One is Snapshot Serengeti. This is where, and so it looks like a National Geographic image, but no, it's just a webcam image taken in the Serengeti Desert, and there's over 1 million of these images in this Snapshot Serengeti project. And what people do is go in and see what animals do they notice. So what do you see in this image? Zebras. I heard some wildebeest out there. Good. So zebras and wildebeest. And they're definitely moving in a particular direction, and I worry about the webcam that's sitting there. And so this was launched in 2012, and in the first, I think it's 3 days, they had over 1 million classifications and had processed an 18-month backlog of data in that research project. Other projects are more on the text transcription side. So there's all sorts of different projects we have, like Operation War Diary, which is World War I soldiers' diaries and telegrams and various writings. And they're cursive oftentimes, so it's computer algorithms fail at being able to transcribe this type of text. And so that's one of our text transcription projects. There are projects like Chimpanzee. So we now include video and or audio projects. And I'll come back to Chimpanzee in a moment. There are projects that also have to do with images, but where you're marking. So you actually use different shapes or colors to pick out, in this case, penguins, another crowd favorite. Who doesn't love penguins? Actually, you know who doesn't love penguins are computers, or robots. Computer algorithms fail miserably at picking out all these different penguins and the overlapping penguins in front of other penguins and baby penguins hidden in there. And so humans are helping to train computer vision classifiers at better picking out penguins, but also for all sorts of different images, objects that we're interested in. And then, as an astronomer who loves having a direct impact in this world and not a very indirect impact on distant galaxies, what I really enjoy this new project that we're testing out called the Planetary Response Network. And the idea behind this one is use all the tools and information and techniques we've learned through Galaxy Zoo, Planet Hunters, all the different Zooniverse projects, and apply it to very real issues here on Earth. So this project takes satellite imaging after a natural disaster has occurred, like an earthquake, and has people tagging images to help the Red Cross and other humanitarian efforts know where to bring resources and know which areas to go to first. So it's a really wonderful application of science knowledge development on real-world issues and problems. All right, so that's all well and good. Zooniverse has these projects, and so we work very closely with these volunteers who are the public working on the projects with us. So I thought I'd say a little bit about who you all are, who they are. So across the whole world, there's people involved in Zooniverse. This provides a bit of a snapshot over 1 year. And it's definitely split about a third the UK, with the center in Oxford, a third in the US, and then a third all around the world. One of the interesting questions or responses we get about why people take part, what interests them. So not surprisingly, some say it's because it's fun and interesting, and they get excited by the beauty of the images, for example. But I love that a big, major reason so many people participate is because they are interested in contributing to science. And so Snapshot Supernova is a project that gives a nice illustrative example of what that feeling is about. So this was a project that took images from the Australian Sky Mapper telescope, and it was a real-time type of project where we needed volunteers to look through images like this one, that blink between a galaxy, and then when a supernova goes off, a new spot of light shows up in the image. And so the Sky Mapper telescope would take these images, and then we wanted to do follow-up observations with a telescope in Chile to confirm whether there was a supernova, a real supernova went off. And so 40,000 volunteers took part. They did 1.9 million classifications. And there were only a few supernova that came out of it that was to be expected. And so the reason I bring this up at this point is because of Adam Wilson. So one of our volunteers, he spent hours and got to his Shawinski number of 50,000 plus classifications and didn't find a single supernova in all those blinked images he saw. But it didn't matter. To him, it was about, as he says, being afforded this opportunity to contribute to an important scientific project. And so whether he hit the jackpot or not, it was about being part of this community that was involved in making progress in science, which I just find really exciting that a layperson, a non-professional astronomer, had this feeling from that experience. So in thinking about this audience and just more, especially those of you who aren't in Zooniverse yet, I thought I'd showcase a few ways that the research teams have really wanted to engage their volunteers more deeply in the research experience. So Chimpanzee was a video I showed earlier, and what the research team has set up is a way for volunteers to go more deeply. So the first step is a regular clicking project where you just say, yes, there's a chimp in that video or not. But then the next phase is, can you identify an individual chimp from video to video and see it doing its thing over time? And so it's about identifying individual chimps. And so that all took place in the discussion forum. This is just one snapshot of it, where there were 8 different sites, so 8 different webcams of videos. And each research team member curated their particular site and engaged their volunteers in finding, well, is that chimp the same chimp as in this other video? And so this is one of their latest blog posts, which is there's this mother-baby pair that shows up in a lot of videos. And the carrot or incentive that we gave the volunteers is, if you're one of the early ones to identify these individuals, then you get to name them. So you have naming rights on the chimps. In another project, Galaxy Zoo, there's this lovely story of a volunteer who, more on her own impetus, went further than the usual interaction. And so this is Hanny Van Arkel, who she's way past the Shawinski number, I think like many, many, many tens of thousands of classifications. But because she really trained her eye in seeing interesting galaxies and had a sense for what might be an exotic object that was real, she noticed this particular image. And so it's the blobby white thing in the top is a galaxy, and that blue smudge is what we later learned is a ghost remnant from a supermassive black hole having ejected material into the surrounding intergalactic medium. And there's only a few of these objects because it's a very short-lived phenomena. And so she was the first to find one of these objects while clicking through Galaxy Zoo images. And when she saw it, she knew to think, oh, this is something special. And so she tagged it to bring it into the discussion forum. And then a whole slew of actual research resulted with her involved in the entire process, including they did follow-up observations with Hubble. And I had the pleasure of hearing her speak at an American Astronomical Society meeting on her and the research team's research results. So it's also just wonderful to see that Zooniverse is providing these deeper research experience opportunities to Hanny, who's a school teacher and definitely not a astronomy background. Another project that has gone further with volunteers that I like to showcase is Disk Detective. So this is a project using WISE infrared data looking for newly forming solar systems in our galaxy. And so in the classification interface, you tag whether the image looks like it has this newly baby solar system or not. But what the research team did, led by astronomer Mark Kuchner at NASA, was he knew there were some volunteers who were just super engaged and hungry to do something more. And so he set up every other week Google Hangouts that the volunteers could join with the research team and have deeper discussions about the research. And then they also really got involved in the vetting process for follow-up observing. So it was the volunteers working closely with the research team who decided, yes, let's pick that object to look at with the telescopes that they were working with, because that looks like a definite potential to look at. And so they were using multi-wavelength data from all different sources, and it was all through Google Docs that they just compiled the information on 60,000 candidates to vet to just a few to do follow-up observations with. So yeah, it's just another fun example. The recent development in Zooniverse, so just as of July, we put out to the public a platform that allows research teams and really anybody who has an interesting data set to build their own Zooniverse project. Because up until that point, so the Zooniverse leads, Chris Lintott in Oxford and I, receive about a few emails every week or contacts, phone numbers, or phone calls with interesting potential research projects to create a Zooniverse project for. And so that's over 100 every year of potential Zooniverse projects. They're really interesting in quality. And our team of developers, 16 developers, can only create about a dozen or so projects every year. And so we were the bottleneck. And that was such a shame because we have this lovely tool for researchers to use and a public very hungry to get involved. And nobody wants to be the barrier to that. So we created the Project Builder, which is a free tool. It's pretty much like a WordPress site. So if you go to zooniverse.org and click Build a Project, you can create your own Zooniverse project with no developer support. You just upload your data, put in what questions you want to ask the volunteers, and then there's a bit of a vetting process to see whether it should be posted on zooniverse.org as a promoted project. And so definitely check that out. Or you can also be sort of ambassadors to the community. So if you know of any, researchers across the disciplines who's sitting on a pile of data that would be perfect for a Zooniverse project, tell them to go check out the Project Builder. And maybe I should do a time check. How are we on? Okay, well, I think, let's give more time for questions. So I think I'll just go to the final slide. And to recap, there's this thing called Zooniverse. Definitely go check it out. If you haven't even been listening these last 10 minutes and just been playing with it on your phone, I love that. There's 38 projects across astronomy, physics, chemistry, biology. There's really interesting medical research projects, but also in the humanities. I didn't mention, for example, AoTATX. Anybody who's really into art, there's artist notebooks that you can go in and transcribe and see the little doodles they do in their journals. And so across the disciplines, researchers using this as a very relevant tool to making progress in research. So if you have any questions or you want to put me in touch with somebody who might have something interesting to do, don't hesitate to email me. And also, for any of you programmers in the crowd, people who are into code, it's all open source. That's part of our premise. It's all about providing tools to the public. And so you can check out our code on GitHub, and especially if there are any mobile app developers out there, that's an area we really want to explore into. So thank you so much for your time.
All right, do we have any questions for Windy City Astro? Shout if I can't see you because the lights prevent me seeing anything up here.
What was that thing that she discovered?
It's called Hanny's Voorwerp, which in her language just means object. So Hanny's object. And it's a ghost remnant of a supermassive black hole outflow from a galaxy. Yeah.
Down here?
You said that those only last a short period of time, but is this what that
Yes. Cosmic scales, tens of millions of years. So, blink of an eye. Yes. Yeah.
Are there any new projects on the horizon that you can talk about?
Yes, maybe you can even help me with naming it. So there's a new project we're working on right now with Northwestern University and researchers around the world a LIGO project, meaning gravitational waves, meaning two black holes crashing into each other and causing ripples in space-time. And there's an instrument called LIGO that detects those gravitational waves, the actual deformation of space-time. And there's a project in which really important for that whole research is knowing what's noise versus real potential signal from crashing black holes and neutron stars. And so we currently are calling it glitch detective because you're looking through glitches to try to sift through what their types are, but that's not the best of names. So if you have ideas for a black hole merger, gravitational wave, Zooniverse project, that might not be glitch detective.
Straight back.
Yes.
How do you know that these classifications that unfitting hemispheres are doing are valid?
Yes, excellent. So that's a point that I didn't bring up.
Could you repeat the question, please?
Oh, yeah, I'm sorry. Repeating the question. So how do you know if the classifications are valid or not? And so in a project like Snapshot Serengeti, so you see that image with all the zebra, and people think that there's a zebra there, but it's not just a single person who's going to tag an image. Every image in Snapshot Serengeti, I believe, is clicked on by at least 20 people. And so you take a consensus among those votes from the 20 different people. And for an image that's pretty obvious, like, yeah, there were definitely zebra and wildebeest there, the consensus is reached pretty quickly. And we've even been playing with retiring objects more quickly. So say the first 7 people all say the same thing. Well, you probably don't need to wait till 20 all saying the same thing to put that into the back drawer and not have more people look at it. But so importantly, all Zooniverse projects are looked at by each image or object is looked at by multiple people. We do a weighting scheme in terms of past performance. So if you've been drinking a little and your performance goes down, we notice it and we downweight your vote. And then we aggregate the results and think about the probability that an image really is that consensus result. Yes. Yeah, we do track user behavior, so we know a ton about your habits. Any others?
Any more questions for Windy City Astro?
Oh,
one down here.
What gave rise to the idea to do this? Like, I know you were looking for extra people to do the work, but like, how did the idea come about?
When I was going through like how many galaxies a single person can process, you just never can reach the million galaxies as a single researcher or even a research team. You really need the power of the crowd to get through your million galaxies. And so some of it is driven by there's just the data volumes we have to process across the sciences. And something interesting happening right now is in terms of we have these data rates and data volumes we're trying to turn through, and machine learning algorithms, computer algorithms, are pretty good at being able to process some amount of the data. And so in Zooniverse, we're starting to look more and more into this interplay between machine learning and human input into classifying a certain set of data, and the back and forth between the two, and humans creating training sets to make the computers work more have a better response rate, and vice versa for these computer algorithms to help train the humans in better identifying objects or exotic objects. So there's really interesting interplay in the human-machine world for Zooniverse right now. Yes.
Okay, let's thank Windy City Astro again.
Thank you.